Hello, welcome to the Dr. Data Show. This is Eric Siegel. And y'all know I have been in the field of machine learning for more than 30 years, outside academia, in industry for more than 20 years. And the industry has changed dramatically about 2.5 years ago with the advent of well-performing large language models and generative AI in general. I think there's no better person to talk to about what that means for us as analytics experts, practitioners, consultants, or consultancies, about what is the changing landscape, the expectations of our customers and clients and stakeholders, which technologies we should be ramping up on, adopting, which hype we should be ignoring or upholding. Then Michael Griebe, who's Chief Data Officer at Hahn Agency, who's also been in the field of analytics for about 15 years. And he's my guest today here. This is, in fact, the very first Dr. Data Show episode with a guest.
Thanks, Eric. Thanks for having me.
But, Michael, it's not your time to talk because I still have to make the big intro. Michael's background as an economist, which he taught at the University of Oxford, and currently manages a team of data scientists, analysts, and engineers at Hahn Agency. He was recently awarded a couple big awards, PR News Innovator of the Year and the Provoke Media Top 25 Innovators in America for PR. He also was recently awarded a patent for the process behind a product that he helped design at Hahn, which is called PRFX. It predicts the business impact of being in the news. So it's another PR play. Also, by the way, Michael will be presenting at Machine Learning Week, the conference series I founded in 2009, which this year, 2025, be first week of June 3rd to 4th of the main two-day program in Phoenix, Arizona. So I'm super excited to talk to Michael about this. He is entirely adopting language models in a really meaningful way, and yet he didn't just pivot his career or his team's focus because he's still very much using the greatest hits of analytics, machine learning models, etc. in general. So I wanted to start by asking Michael about your anything else about your background I might have missed to inform this conversation, and perhaps start with a couple or a few example projects you've been working on at Hahn Agency.
Sure. Thanks, Eric. First of all, thank you for having me. It's wonderful to be here. I've been listening to your show for a while now. Right. So I'm working on a bunch of different models like you mentioned. Most of my work is still firmly in the predictive analytics. We have pricing models that predict vendors' pricing. We have FuseLight, which is this product that, you know what a collab is, Eric?
A collab.
Yeah, a collab. It's when a brand and a celebrity get together and they try to do some sort of co-marketing partnership.
Right.
Yeah, so what FuseLight does is it's a predictive model that quantifies the hype.
Right, and that's the product. That's going to be the topic of your presentation at Machine Learning Week, right?
Yeah, that's right. So it quantifies the hype of collabs. That's a predictive analytics play. We use AI, we wrap it in AI to make that model more user friendly, because predictive analytics models can be a little finicky with its inputs. And so having something interpret human inputs makes it more user-friendly. As you mentioned, we have PRFX. PRFX predicts the business impact of being in the news. And most recently, we've been building voice assistants. These are essentially customer service reps. We have some clients that we've deployed these call assistants for, and they've been really remarkable. Something really special that's we're able. In the past, if you were to try to build something like this, it takes sort of months and the development time has radically dropped. You can start to produce something in a week that's going to answer customers' questions and understand what they're saying, and be really smart about it. Something that's just hands down better than something like an IVR.
Yeah, that's awesome. So you're talking about a large language model driven AI system basically acting as a customer service agent, fully autonomous.
Yep.
And that's obviously one of the sort of main visions of the dream of generative AI. You kind of unleash it on the general public. And that's a really interesting one to me because I haven't really seen that very much yet, where for consumer facing use cases, it's actually deployed out there, running, unleashed on the let's say unsuspecting consumer who's suddenly talking not just to sort of the robot that you might have been accustomed to over the last 10 or 20 years, but it's actually language models, so you can chat ad hoc. You can phrase it however you want.
Yep.
It can sort of assimilate and bring in information in the terms that you ask. It's much more closely related to interacting with a human. So I wanted to ask about that because it's very cutting edge in the sense that everyone knows language models have potential to make mistake, hallucinate, or create problematic content, and yet they've certainly gotten a lot better. And yet I, at least personally as a consumer, I don't really have the data, haven't seen it that much. I mean, I think that I know enough, have enough experience that I would know it when I was talking on the phone and it was actually a large language model based, let's call it agent or assistant. So I wanted to ask about your experience creating that product. I asked you, we were talking, our working friendship is based largely on predictive AI, not generative AI. My professional focus is still largely predictive. The conference you're speaking on is about 50-50, predictive and generative. There's a track on hybrid, and you're included in that for the reasons you just mentioned with that product. But but at the same time, I'm certainly not blind to language models, interested in how they fuse and interact with predictive models. So I'm interested in how you kind of crafted this solution, how you sold it so that it would get unleashed. To what degree are there potential problems? How, what's the scope of its capabilities, what it's doing for, and I think we can say it's for a healthcare insurance company, right? Mm-hmm. And it's providing direct access. Any one of their customers can call up and talk directly, basically just chatbot using voice.
Yep.
So what's the scope? How many different kinds of problems can it handle? What's it meant to do?
Yeah, so first off, hallucinations are a big problem. They still are a big problem. And one of the ways you handle that is by trying to circumscribe the scope of the things that the AI can handle. If we were experiencing... If we had we were trying to, one of the things my company does is focus groups, and they asked my side of the shop, the lab shop, hey, can you do something that's going to transcribe all of these focus groups and come up with the key bullet points? And we found that if the text got too large, they would hallucinate. The AI assistants would hallucinate. So we started thinking of clever ways to shrink that, and our first option was to shrink it down to just 5 pages, and it turned out that sort of eliminated the hallucinations that we were seeing. And so that's one of the main ways that we try to make these AI assistants work properly, is by really reducing the scope. Now, in this particular assistant for the healthcare company, there's obviously a lot of privacy concerns around the data that could be available to any automated system. The knowledge base for this system is simply an FAQ. You can access the same FAQ on the website, but by feeding it into a large language model, it can answer any of those 27 questions and any sort of variation or combination of questions that someone might have. And so what happened is the this healthcare company, due to a shift in the market, had a sudden rapid increase in the number of calls that they were getting. That's open enrollment period ended, and suddenly they're getting or started, and they're suddenly getting 3 times as many calls as they got in the year previously. It turns out that their prices happened to be lower than their competitors, and they were, as a result, much more popular. And this is a problem. This is a problem. If you're staffed for 4,000 calls and you start getting 15,000 calls, it's a problem. So their queues were getting really long. They had like a week wait time. And by the time they started speaking with us, their wait times were growing faster than we're still growing each day. The total wait time, the total queue is growing faster each day. So anyway, and 80%, 90% of these calls were things that could be answered from using the FAQ. So anyway, so what we did
is... Did you have to work up a pilot or a trial system in order to sell this to them? So you kind of created a first pass on it?
Yeah. So we had already had some architecture in place. And the client mentioned this on a Friday morning. We were pitching it internally to our teams by Friday at noon, and we were pitching it to the client at Friday at 4 p.m. And we put a proof of concept for them to listen to because it was a crisis, 8 p.m. Friday.
Wait, you made a proof of concept system for them to try out?
Yes.
Within a day?
Yes. They were calling the system.
Now, it sounds to me from what you were saying, this is largely an exercise in some very astute prompt engineering based largely on a FAQ they have on their website that answers these main 27 questions, right?
Yep, that's right.
So, and from what you told me the other day, if the system can handle those questions, it pretty rarely has to then pass the consumer on to a human agent, and that kind of takes care of the lion's share of calls. So that's amazing. But in this prompt engineering exercise, in that first pass, which happened in less than a day, did you take the FAQ and then just give it to the language model, or did you do some changes to make it a better prompt? And then same question for the actual production system.
So the prompt evolved over time. We went from a proof of concept system. Remember, they were having major problems. They needed a solution right away. And we went from a proof of concept solution to in production solution in 6 days.
Within 6 days, it was ready for production, or was actually...
it was running. It was Friday is when we showed them the proof of concept. The next Wednesday at midnight, we were live.
Okay, so that's pretty fast. So, so how much of that time was actually creating the prompt and testing the language model, and how much of it was sort of everything else, stuff that I personally don't know anything about? You're going to connect it to a telephone system. I guess connecting it to speech recognition and speech synthesis was clockwork because you were using an existing LLM-based system that already had that built in. So
almost all of it was prompting.
How many pages is the original source that's like on their website, and how much longer did it end up being once you'd sort of engineered it? You know?
Yeah, it was about 3 times as long. It was about 2.5 pages on the website.
So you just sort of had to spell out a whole bunch more, make more explicit for the language model to know about the meaning of all these.
Yes, and you also had to spell out special instructions on how to handle certain things.
Right, and I know that you put guardrails like don't answer questions about X, Y, Z.
Don't answer questions that are outside of scope. Pretty much, yeah.
Did you enumerate explicitly things that are prohibited to talk about?
No, we didn't.
You didn't?
No.
Oh, okay. Wow, that's amazing. So in general, I mean, it sounds like this is the kind of thing LLMs clearly excel at, and I have had a parallel experience in my own work where when it's a sort of finite scope, well-defined, and then it's going to do a pretty good job getting the right answer in whatever turns of phrase and normal natural language people want to use.
Yep.
and you've kind of become a proof of concept of that not only does it work and you can try it out and it seems cool and someday we should deploy this, but you actually got it deployed. And again, I don't have the data, but my sense as a consumer is that we're not seeing too much of that right now. In my experience, every time I call customer service, I'm still kind of getting the old-fashioned thing that's doing its best to avoid me talking to a human, and that still has great limits, and certainly not language model. But there's obviously upside to being large language model driven, as you've done here. Do you think that this is just inertia? Do you think that there was some special sauce in your solution and or in your sales tactic, to the healthcare company, your client, that made this kind of cutting edge step possible?
Well, so one of the things the pain of the current system was being felt acutely at the time that we offered a solution, and that's part of the reason why it got implemented so quickly. That's part of the reason why it was a yes. We handle 75%. The AI assistant handles 75% of the inbound calls, meaning that only 25% of the people after speaking with the AI assistant need to get pushed through. Mm-hmm. Now, in a slightly different circumstance, that might sound like a bad stat. Right? You're like, well, you're 75 it only handles the situation 75% of the time, even though you limited the scope. And we're like, yeah, that's so some people, if you're not experiencing a direct pain, this might not look attractive. But so anyway, there's that.
But it should be a win whether. So the pain, I think you mean by the pain, you're referring to the fact that this healthcare company had suddenly had the dramatic increase in incoming calls.
Right.
So they had a kind of a crisis.
Right. So if your system works perfectly,
yeah,
it's handling all the call volume. Your KPIs are within, normal bounds, and you're happy with what's going on with the KPIs. And then someone comes along and says, "Hey, we can write an assistant that's going to handle your calls." They're facing a different. They're not facing that pain. Even if you could save them a bunch of money, the step that they would need to take to save that money is to let go of people, and that hurts too.
Yeah. So, what would you say are the limitations that could grow to be concerning, or what kind of QA still stands to be done on the existing solution, and are you approaching that?
Yeah, so one of the things that's problematic is these systems, for the most part, they get tested by trial and error by humans, and it's a slow and painful process to call up an assistant multiple times, make sure come up with unique scenarios, and make sure that it works for those scenarios. It's and so we're developing a system that sort of works that helps on that front. So that's one of the problems. The other one is AI assistants. People don't necessarily treat them with respect that they would a human, and that can be problematic because you're designing a solution from a human's perspective, right? Like what should a human do in these circumstances? But an assistant might face new and different circumstances for the sake of being an assistant, for being an AI, not being a human.
And so you're saying a human could be like, oh, I have nothing to lose. I'm just talking to a machine. I'm going to treat it however I want. I'm going to talk however I want. And what's the downside there is that I assume you're not concerned about hurting the machine's feelings. So what could go wrong?
Okay, so for starters, it could give unclear answers. One of the things that humans might do is they might say like, bill pay, right? They'll just repeat a really short phrase repeatedly because they know that they're dealing with a machine, and they've sort of been trained from past experience that's how that they think that the machines are listening for specific keywords. And so that's problematic. But there's also there's the potential for in some systems there's potential for abuse. There's In this particular case, all the whole knowledge base is public knowledge. But let's say you had special circumstances that if the assistant heard about these special circumstances, they would behave differently towards the user. And you don't, that's not secret that they're these special circumstances, but you don't want to publicize them because you don't want to give everyone the special circumstances, right? So for instance, let's say someone calls in and they have an urgent need. You want a human would detect that urgent need and behave according to a certain pattern of behavior, where and you want to, if you want to replicate that in a system, you want to keep that knowledge hidden and undisclosed. Now, if you're abusing an AI, you can try to get it to reveal its instruction set. Right, you can try to, the metaphor of like popping and pushing the stack and programming. Sure. Yeah, you can try to pop out of the current context, which is weird, and try to get into a wider context, and then in that context get the instruction set out. So that's that's a possibility for abuse in that vein.
Yeah. So would you agree with this characterization? Like, when you move from a much less constrained system of your sort of typical automated service to something driven with a large language model, the upside is that it's much more natural in the sense that you can talk to it like a human, any turn of phrase, it understands, it can deal with metaphors, and it can connect that to the knowledge base you've provided it, and actually provide the pertinent information to the end consumer. But by the same token, it's then therefore less constrained, and somehow there's this much wider range of possible scenarios and therefore things that could go wrong or room for discovery of sort of humans with either indifferent or malicious intent of sort of stumbling into that. So my first question is, would you agree with that way of I'm characterizing it?
Yeah, if you take a system like an IVR, an interactive voice recording, it's like press 1 for, there's no room for abuse.
Right, sure.
They can press the 6 buttons, that's it.
It's just a tree menu basically or whatever.
Exactly. But if you take a really smart system, a really intelligent system that does more than that, then yes, you can get it to reveal things that maybe a human wouldn't reveal.
Okay, so the second part of that question I have for you is, do those concerns, do the risks increase when we then move to more ambitious projects where the large language model driven AI assistant is now meant to handle a wider scope of knowledge, maybe much more than just several pages of prompt engineering, documents, and or sensitive data, and or the ability to actually engage and enact some kinds of transactions. So does that increase it, and then where do we have to go to approach that problem?
Yeah, as the assistants become sort of more powerful, as their set of possible actions and powers grow, yes, the risk of abuse from a person that is aware that it's an assistant, the potential for harm there does grow as well. There's a few ways that I suspect you could mitigate this. The first is, you need comprehensive testing. So one of the things that we're working on, that we're developing right now, is we're developing an AI assistant to test our AI assistant, sort of end to end. That way, instead of having just a few humans run through a handful of tests, making calls using their imagination. So instead of doing that, we have an assistant build hundreds of profiles. Each of the profiles has a specific intent, and some of those intents could be malicious in nature. And then you send all of those agents to make calls to your development system. It poses all these questions and takes notes on the results of their conversations. And then you use that to determine, how well the AI is performing in very short order, just a few minutes. And you also use that to come up with ways to make it better, to sort of lock it down more. So that's one method of going about that. But there are others. There's more that you can do in that space.
That's great. So you've got the language model testing itself, basically.
Yeah.
Taking on different personas. You're stress testing, but you're scaling that stress testing to create all different kinds of scenarios where it's trying to do something you wouldn't necessarily want to be able to do, or doing things in a unpredictable or way that you're not expecting from a cooperative consumer, and then you're evaluating according to whether whether they break it, whether it says something bad, whether it gets it wrong. Like, what are the different criteria you're checking for?
Yeah, so sometimes we're so we try to run it in different languages, and so we want to make sure that it's picking up on the correct language. That's an easy one. Another one is we're checking for, does it correctly identify the intent of the consumer? So we know what the intent is because we know the profile. And then on the other end, we ask it at the end. At the end of the interaction, we just ask, what was the intent of this call? And if it's correctly matched, that's great. We also, we can detect, if there are things that, we ask it, was this customer, did this customer behave strangely or in a way that is inconsistent with an intended, a typical caller? And it can report back on that. The checklist, we're finalizing the checklist right now, and it's going to change as we think up more things that the AI assistant can check off. But yeah, you're right. What we're doing is we're building an AI assistant to check the work of the other AI assistant.
Right. Okay. And are you testing this now on the production system that you had for the healthcare?
No, we test we're testing it for that client, but we do all of our testing on our development system.
Right. But I mean, are you doing it, is the intent of this project to improve that existing production AI assistant, or is it more generally just to use that as a test bed for capabilities that may become more important when you have a wider scope AI assistant, or is it some balance between the two?
It's both. The immediate use case is trying to help this AI assistant, but really what we're trying to do is collapse the development loop. Because I know it sounds really short right now, but the way we did it in 6 days. But keep in mind, that was part of the reason why it was so short, is because it had to be. Every single day was extra problem. So we had to put something. If we'd had more time, we would have used more time. Now, what I mean by closing the development loop is, you have a script that handles the plumbing, and you have this. You may have a knowledge base that you use in a RAG architecture, and then you have this prompt, and the developer has an intent for how they want everything to work. And right now, it's a trial and error. You get five people from your company to make phone calls or try it out themselves, or go to the chat and work on it, and then see if there's anything strange happening or if it's answering appropriately. And that takes like half a day to get 10 responses from people. What we're hoping to do here is, get 200 responses in 2 minutes and put them on a bar chart, right? And show statistically what's happening. That feedback, right, makes the developer much more aware of what he's building and what's going wrong with it, or she.
So as far as whether it's getting things right or wrong, what's going wrong with it, one of the things you just mentioned was that the pretend consumer, right, which is in this case now just another LLM that's calling in to check it out, to test it, has a preordained intent or problem that needs to be solved, by which I assume you mean for this case where you said there's like 27 FAQs, right? Is the intent like, I need the answer to question number 30, question number 24 or whatever?
Yes. It'd
Okay.
be like, I need my member ID. Right?
Okay. So then how do you, for each of those cases, and you're trying to automate this testing so then it knows whether it was a positive or negative outcome, how does your automatic testing system know whether the AI assistant answered the right question, fulfilled that intent?
Yeah, so the testing bot is sort of like a secret shopper. It's got its own little checklist in its head.
Right.
It goes through the conversation, and at the end, it fills out its checklist.
So it knows whether it got the answer to the question.
Exactly.
Okay.
And then it stashes it in a database for us to visualize.
Okay, cool. So, one of the things I've been thinking about a lot, and I'm going to be giving a couple talks on this, is ways in which predictive and generative need to be hybridized. And one of the main things is I'm operating under the assumption, and I would love to be corrected, but I'm operating under the assumption that language models are incredible, unprecedented, extremely powerful, and adept. But then when the scope gets bigger than these sort of finite scope scenarios where you're really pushing its limits and it does have potential to either hallucinate or get things wrong or what have you, that there'll be a place where we want to use it even though we're in an arena where it's not nearly as reliable. It might be totally wrong up to 5% or more of the time. Mm-hmm. So I'm thinking that's where we could potentially hybridize it. Mm-hmm. And you and I recently sort of chatted about that, but so I'm just trying to revisit our conversation for the public.
Yep.
But what do you think about that? Like in alignment with what you just described, you're collecting data about the performance. Would there be value to then model in the traditional sense of model, not a large language model, a predictive model, a machine learning model, to model on that data so that there can be proactive interventions, so that chats with the end consumer that are potentially going to go wrong in some way, that could be nipped in the bud proactively, predictively with a model. What do you think about that general?
Yeah, so I see two main problems with AI right now. Two main branches of issues that, the next billion-dollar company is going to be solving these. The first one is that you can't hold AI accountable. Like you can destroy the model and recreate it. You can tell it, I didn't like your answer and give it a thumbs down. But neither of these things hold it accountable. Accountability is somewhat related. It's related to a network effect between people, and I don't know how that gets replicated. The second problem is that humans don't have any respect for AI. That respect. Now, I think that respect comes from. In some sense, if something has if a system has the ability to harm you, right, in some way, or deny you service in some way, then or change the type of service that you get, if it has some of those characteristics, then you might begin to respect it. If you try to use it in ways that is not intended to be used, and it changes its behavior because it's recognizing that would give you as a user an incentive to treat it the way it's supposed to be treated. So. Yes, in this vein, I think that there's a way that predictive modeling can be used to detect if someone is, if a conversation that's being had with an AI is likely to lead to a bad outcome, right? If it is likely to lead to a bad outcome, you could try to intervene in that conversation and either send it to a human straight away, or shut down the call altogether, or change the nature of the service, right? But from my perspective, the way that this is a statistical issue, and it's a probabilistic one. This one doesn't feel like the sort of thing that you could just have the AI think about whether it's happening or not.
Okay, so I think what you're just to try to unpack what you said with listed these two main problems. Am I correct? You're talking about the kinds of things that contribute to the potential problems, especially as we do broaden scope, increase ambition of what the AI assistant's meant to do, and how much it's supposed to be able to handle, and the power, as you put it. But the way you put it, humans not respecting AI, I guess, is this the correct paraphrase of what you're of what you're saying? Is that because the human knows they're not talking to another human, their guardrails are off. So there's so many directions that are hard to anticipate they could go in. That would push the limits of the guardrails you hope would be enforced in the language model. So things could get problematic in several different ways. So when you're talking about respect, you don't mean that we owe machines respect.
No.
You mean the human nature of that. I mean, I don't respect this couch the way I respect you. I'll be honest about that.
But you don't jump on it, right?
But that's only because you're here. Otherwise, I would be jumping all over that couch. So it's just that there's less guardrails in the interaction with the language model. And then you also said AI is not accountable. You mean in the sense that it doesn't have the same incentives as humans, so there in unexpected circumstances it could break rules in ways that we wouldn't anticipate. Is that what you mean?
Yeah. I just mean that in a broad sense. So I don't have a solution for that one just yet. But in a broad sense, the lack of accountability means that this is the problem. This problem is why we don't have self-driving cars yet. Right? Who's going to accept the liability? Mm-hmm. Right? Is Tesla going to accept the liability? Right? Or is the driver going to accept the liability? Right? You can't hold the AI accountable. You can't say, "Oh, you wrecked my car, AI. I'm taking you to court because you weren't thinking properly at the time." Right? You can't do that. Or if you hire, if you're to deploy an agent to make decisions on your behalf, and it buys. There's an article about a guy who, I think here in San Francisco, got asked for it to buy some cheap eggs and bought eggs for like $30 or something like that after all the fees and everything else. Like there's no way to hold the AI accountable for that. It's not like you can admonish it and then it's going to take extra care next time.
Now, the self-driving thing, that's a great point. I think that there may also be limitations to its capabilities. I mean, sure. You can be just the same as with a language model. You can be astounded with how seemingly human-like its level of capabilities are, but you have to test it. You can't just sit in a self-driving car for 500 miles. You have to sit in it for 5 million miles before you really know what it's made of. So its robustness.
Sure.
On that extensive, that on just sort of its technical capabilities, there's not a lot of transparency on that either. But I think those two things maybe go hand in hand. Whereas with the kind of enterprise deployments of AI assistants, if you will, that we're talking about, you don't have the same life and death. And to be more precise, if you had a model that says, "Hey, something's about to go terribly wrong, let's disengage autonomy on this vehicle," well, the vehicle's moving 50 miles an hour, and that's not something you can just change instantly, right? Whereas if it's a LLM interaction, you can just literally stop it in a split second as need, if absolutely needed, and or divert to a human or all sorts of potential interactions. That is totally plausible and doable. So I think that's what you're saying is, as the risks of more ambitious scoped deployments come into play, there can be value to playing it by the numbers and having a model. And so that's something that I've been thinking about. Again, I'm surprised I haven't seen too much of it, but I've been seeing it with other types of AI systems like speech recognition, where you just put a sort of traditional ML model on top just to manage and increase overall robustness. So
we're in the happy days of AI, right? We're in the 1998. If this was the internet, we're in the 1998 of the internet, where we don't have a lot of. We may have some people exploiting it for negative purposes, but there isn't this avalanche that requires a whole host of security solutions just yet. That's where we are with AI. We're still in the happy days. And then developers, I like to, I don't know if everyone talks about this, but when you first start off designing a solution for a client, we talk about the happy path. The happy path is like, if everything goes to plan, A happens, and then maybe an if-then statement, and then B happens, and then an if-then statement, and then C happens. And there's no errors happening, or it's no like, oh, what if the Wi-Fi is interrupted in the middle of this? You're just looking at the happy path, right? Well, eventually, when you finish your development, you don't have just the happy path. You have a bunch of paths, but they're all, they can all be written down and shown in a simple diagram, and you can plan for them. With a LLM, there's the happy path, sure, that we're all developing around, but then there's all the other paths. That's and it's there. You can't enumerate them. The human language is varied, And when you're dealing with these systems, they can do any number of things that's hard to anticipate. Just a delta, right? A Nile River delta of possibilities, right? Yeah. And as a result, that's why I'm saying we have to deploy human type solutions. Now, the human solution to dealing with humans is reputation regime, right? It's, I feel like something's weird about this conversation. I'm going to disconnect and stop talking to you. Or I'm not going to just continue in good faith forever, right? If I feel like you're fishing for my social security number, I stop responding, right? So that, or any other secret information I have.
That actually brings me to the next question, which is, what is your social security number?
So anyway, the idea here is that, if we can put in a predictive, like a nowcast that's listening to the conversation, that's anticipating whether or not this is going to lead to a bad outcome, right? If you have the data on these bad outcomes and we can generate it, then you can put a system in place that is reputational in nature, at least for that interaction. Maybe it doesn't stick with the customer or user forever, but at least for that interaction, you can try to detect if something's going strange and stop the call. So
you say the happy days in the sense that I think what you mean is that as the scope of these and the quantity of these types of deployments grows, there'll be problems will start to emerge as the humans start to exploit or happen upon vulnerabilities. And that kind of reminds me of sort of happy days of credit card industry. My understanding there was early on, especially before it was electronic, a lot of these transactions, there was a growing amount of fraud, and that the credit card industry was really looking at pretty negative outcome, and then fraud detection methods started coming in and intervening and made it back all manageable. Kind of like email, right? Email, if it weren't for spam detectors, right? It would just be so noisy. The productivity and the usability of email. I won't make any side comments about LinkedIn where there is no spam detection, but so that's quite interesting. So and I'll be very interested to see how that can sort of end up being a comeback maybe for predictive AI, or one of the most important things to allow generative AI to realize it's the dream, the sometimes audacious dream that's promoted. But so taking a step back though, then as I started out our conversation, I'm like, look, the industry, the analytics career tracks, the landscape, the expectations of our stakeholders and customers changed so much with the advent of generative AI so recently, and it's almost kind of bifurcated between predictive and generative. You seem to really still be working very much in both areas with your different client projects. One of the projects, I think you might not even have mentioned, that you're doing dynamic pricing. Which is a bit more on the traditional analytics side. By the way, I don't like it when people call it classic ML or traditional because it's older, but it's not old school. Most of its value is still largely unrealized. Like, let's not diminish it. It's different, and it's definitely not as sexy as generative. I'll give you that. But the value there is potential. They solve different problems. So my question to you is, which do you like better? You've got projects in both. You've got prospective projects in both. You've got all different business directions that you could focus on and try to cultivate more in terms of client engagements. What's your whims, right? Where do you think is, just subjectively, like, what do you like better? Which of the projects do you like better? Which is more exciting? And then just sort of practically speaking, where do you see the biggest opportunities?
Well, the generative stuff at the moment is... there's just a wide blue sky, and it's like a new set of problems that you can try to solve for clients, which is really exciting. The thing I worry about from a career standpoint, or for running my shop standpoint, is that it is very difficult at the moment to create a moat around your business when it comes to generative AI. the solutions that you come up with or dream up or build today that solve something for a client, you might be crushed by some giant that decides to roll out the plugins necessary to make your work, in that space obsolete. So, whereas I don't feel like that's the case with predictive analytics, it is still a bespoke and difficult study. It's something that there's still tons of use cases. Like, you ask anybody, do you think, any company, any CEO, do you think that you're using all the data that your company produces to the best of its ability? And none of them will say, yep, absolutely, we've got it all under control. Right. None of them. So there's still a massive opportunity, a massive scope in those spots. It is, those problems are hard to solve. They're generally, and sometimes the clients don't know the pain, right? No one feels the pain of, I'm not optimized.
Yeah.
That's not a pain people have.
Not optimized. Okay.
Right.
Well,
but that doesn't mean there's not value.
But they're throwing a couple dollars at this new exciting thing.
Sure.
So there's that old adage, nobody buys anything unless they're trying to eliminate some pain. Mm-hmm. But then there's what's happening now with the generative AI craze, where the valuations, the investments, and then the investments of corporations, right? And they're doing it because everyone else is doing it to a certain degree, right?
Sure.
So what,
sure.
That's sort of like is that because they're expecting pain if they don't keep up? I mean, how would you put it into that framework?
Yeah, I don't know. But I mean, right now I feel like there's a lot of testing, a lot of trial, a lot of curiosity, right? From what I see, even within my own shop, the inclination is, you find out that that an AI can do something, and then you ask yourself, should I build around that and deploy, right? And I find myself increasingly coming back to this idea that unless you're attacking the meat of someone's work, right? If it's just something that they only need to handle once a week or once a month, right? Then I'm of the mind that you're not going to do that. You're not going to build a solution there. Either someone else already did and you can use it, right? Or ignore it, avoid it, because it's because basically the biggest obstacle to deploying an AI project is another better AI project that you should be deploying instead.
Right.
And so, and if you get on that treadmill, you got problems. You got serious problems. You get 2 or 3 losses on your books, and those losses look like this. You build something, and internally people don't want to use it. You do that 2 or 3 times, your inertia's gone. Right. So anyway, there's a risk there, and for me, I used to think about blockchain. I was like, it's a solution for a problem that no one has. And then I look at AI, and it's like the opposite. It's any problem can be solved with AI. Is sort of what it feels like right now. The question is the problem worth it?
Right. And it's, for some of these finite scope, well-defined, it's turning out that the language models just do so well so long as you sort of prompt it well enough. And they are very effectively general purpose, at least if you have your head on straight with some realistic scope goals and such. So before we wrap up, I just want to circle back along those lines, something you said a minute ago about this lack of moat. You were kind of like, one of the main ways you differentiate as you navigate your consulting work between predictive and generative AI is that, well, with generative, it's because these language models are so effective and it doesn't sort of require rocket science for certain projects to get it to work, there's no moat. It's like, how do you compete out there? It's not off the shelf, but it's sort of within some number of inches away from that in a sense. On the other hand, what we were talking about a little bit earlier is layering some enumeration on it. You're doing a battery of automated tests.
Yeah.
So you're getting the numbers, and then maybe even creating an ML model. So you are doing some bespoke number crunching on top of it, to the degree that for any kind of reasonably ambitious project that ends up being important, as we push the limits of larger scope AI assistant projects, doesn't that sort of bring the scope back?
Sure.
So
yeah, ML can do that.
So sitting here right now, where do you see your career or your team's work, or what sort of feels most potent or interesting or exciting to you when you if you agree with sort of dividing it in these two parts, predictive and generative?
Well, I think the hybrid is interesting.
Yeah.
Because it's the hybrid approach is interesting because there's just you can build bespoke solutions that are smarter even than your competitors. So I mean that's probably where I'm going to lean. Yeah, that's where I'm going to lean. Put my chips on these hybrid systems.
Yeah, I mean, my pitch for hybrid is sort of like both. Instead of it being two different fields, as it's sort of becoming, even though they're both under the quote AI umbrella, maybe they'll become less differentiated. It'll all come back together to a big mix, and you can't get the best of both worlds. You can't get the best of either without the other. They need each other. So I'll wrap up by pitching Machine Learning Week, first week of Phoenix, where we'd have an entire track devoted to the overall conference is about half predictive, half generative, but we have a whole track which includes Michael's talk on hybridized approaches where you're getting the best of both worlds in that sense. Mm-hmm. You were going to say something?
Yeah. So the funny thing is one of the shortcomings from a predictive analytics standpoint is that it's been really hard to get just enough structured data from people. One of the things that you can do with an AI is have it write down every single little structured piece of information that's going into its thought process, right? And put it down in a ledger for you to build your models.
I mean, turning unstructured into structured is one of the main hybrid bullets that I have in mind for my opening keynote at that conference, right? So,
exactly.
Yeah. So that, I mean, it makes structured data for you in all sorts of ways, for sure. There's a lot of ways. I mean, the difference between predictive and generative is really there are two categories of use cases of machine learning. And so when you kind of conceive of hybridizing, it's not that you're hybridizing two different technologies. Yeah. It's two different use cases, but basically one use case can be framed as the other, essentially. Or in other words, you're taking generative AI projects and helping them be better with a predictive model, or vice versa. You're taking a predictive modeling project and you've got a chatbot that's helping you navigate the project, or you're doing automatic coding of how you're using sklearn for running the project, or all that kind of stuff. So it works bidirectionally in that way. But I do think the winner potentially is ultimately going to be improving of robustness. So any last thoughts, Michael? I really appreciate having you. You've been great, very first ever guest on Dr. Data Show.
Well, thank you for having me, Eric. I really appreciate it.
Yeah, my pleasure. It's been great. I think we'll get a lot of good responses. Thanks everyone for listening, and have a good one.